Cool. All right. We're at time, so we're going to kick this off. We're about to talk about putting our database as a service platform on Kubernetes. So quick intros. I'm Steve Croce. I'm the product manager at ObjectRocket for our hosted Elasticsearch product. And with me?
Wes Ashkinazy. I am the engineering lead and development lead for the Elasticsearch product.
So just a quick intro, if you're not familiar with ObjectRocket, we are a database as a service company. We currently host MongoDB, Elasticsearch with Kibana, and Redis. Our real focus is on support, so we attach 24/7/365 support for pretty much every customer. There's no upsell there. And really our goal is to provide free migrations, free upgrades, all that stuff to basically be your database ops team. So just a quick intro on who we are. Okay, so what we're going to go through is we recently made the decision to move our platform to Kubernetes. So we're going to talk quickly about why we did that and kind of what was driving us to do that. Before we dive into getting the platform onto Kubernetes, what challenges we ran into and how we solved them, and then where we're going next. So current platform that most of our customers are on today was built about 6 years ago, built in 2012. Mainly, we used OpenVZ as our container technology at the time when it was built. That was probably the best game in town for us. And everything was custom when we built this. We had a goal at the beginning, in the very beginning of the company, to be kind of the absolute fastest hosted MongoDB. MongoDB was the lead product. And so everything was custom built. It all runs on our own bare metal environment. But since then, 6 years is a long time in technology. A lot's changed. There's a lot more available to us. Docker has now become the de facto container formats. There's a lot of opportunity for us to move off of what we had. And then also custom orchestration, there's no reason for us anymore to do it. Things like Kubernetes have gotten really capable enough that there's nothing we could do ourselves that would be able to beat what we get from the community today. And then the final piece, and this is one of the real drivers, is we needed to be able to stamp out our environment in any cloud we wanted to. The bare metal environment we're in, it's great for the customers we have today that want the absolute fastest thing. But for everybody else, we get a lot of requests to once again move our databases closer to the application. So that's the quick kind of outline of why we're moving everything and kind of building a brand new platform. And so this is kind of a little nod to the rest of the presentation, and we'll go through this learning curve we had, where and we'll talk about when Kubernetes was easy, when Kubernetes wasn't easy, and how it's getting easy again. And you'll see on the top right, we'll have some of these little gauges. And so the green, they're the areas where Kubernetes actually solved our problem really easily. There's the reds where we had to kind of invent something to solve a problem. But yeah, we'll go through this kind of this journey and this path throughout the rest of the conversation.
Right. So, little context. When you're looking at Kubernetes and these orchestration platforms for hosting stateless services, web apps, workers, things like that, we were all excited. When we're talking about putting stateful applications on there, a lot of red flags hit from the dev team a year or two ago. A lot of these platforms weren't really designed or up to snuff yet to run stateful applications. We all know databases don't really tolerate failure that easily, some better than others, and operators really were still just becoming a thing to work with. And just for some context about what our platform kind of looks like today, we're going to have an infrastructure API. We've centralized logging, monitoring. We use Envoy for ingress. We've got some Fluentd, some Weaveworks. We have clusters in multiple regions in our alpha program. And with all of that, we're just focusing on this kind of small bucket today and how we manage a stateful database in our platform. The presentation is going to follow a flow. So we're going to start with all of these combined are the table stakes to really host a database as a service. We've got the basics, which is kind of how we create and manage clusters. There's security for those clusters, database administration and automated tasks that every database needs, and then really the service features that take it above just managing a database for somebody.
All right, so the basics. When you are launching a database as a database as a service, or even just a database in general, like the operator that we're going to talk about throughout this presentation, the most basic thing you need to do is create a cluster, make sure that cluster stays alive, and then get rid of the cluster when you're done with it. So without getting into too many specifics, once again, given that we work on the Elasticsearch product team, I'm going to talk about some Elasticsearch specific pieces. So I want to show you what one of our clusters looks like, just so you have a little bit more context about why we're doing the things we're doing. So just at a very basic level, our smallest cluster, 3 nodes, 3 nodes that operate in all the roles. Elasticsearch does have the capability of being specific about node roles, but in the smallest cluster, we're just going to have all 3 perform all the roles. We have some endpoint that we offer that load balances between those 3 nodes. But then off to the side, we also host Kibana, which is a visualization package. It's part of the Elastic Stack. We've got some other dashboards that are available as site plugins, which also need external access. But then we also have some other tools that we run internally. So Curator is an index management tool, and ElastAlert is an open source alerting tool. So that's kind of the base cluster. When you create a cluster and when we host something, this is kind of the default stamp. But then you can add on to that. You can add more nodes. You can add more specific nodes and specific roles. You can also add other tools like Logstash, which are things that we'll all support once once we're fully live with the platform. So the thing that makes all of this, kind of possible is operators. And, anybody, if you've all been here the last couple of days and watched the talks this morning, there's plenty of overviews about operators. And so I'm not going to go into too much detail about an operator. But just from a high-level overview, not a deep dive, anybody who's not familiar, Operator gives us the ability to basically create custom objects within Kubernetes. There's 2 main components that we refer to. There's the custom resource definition, which is basically defines what your resource is going to look like, and then there's the controller. Since Kubernetes doesn't natively understand this custom resource we created, what the controller does is intercepts any actions against that resource, performs whatever logic we want to, and translates parts of it into things that Kubernetes can understand and work with natively. Basic example of that, if you look at the left side, this is just an example of what our custom resource looks like. It's got a Elasticsearch multi-role kind, which Kubernetes doesn't know what an Elasticsearch multi-role is, so we have to tell it. We create a custom resource definition that kind of defines what fields and how that manifest is going to look. But then also our controller can then take that manifest and turn it into things, once again, that Kubernetes understands. So turns it into some stateful sets, some services, some secrets, some cron jobs, and lots of other things. And then also performs some custom tasks along the way. So once again, not a huge deep dive on operators, but hopefully enough of a groundwork that if you're not familiar, you can kind of keep up through the rest of the conversation. So when we set out to write this operator, there was kind of three paths we had, or the 3 paths that kind of made the most sense to us. We could use an off-the-shelf kind of open source operator. There are a couple of good Elasticsearch options out there. We could use a library, a utility library. There's one out there called Cooper that looked interesting to us that would allow us to standardize across all the different products. Because once again, we also have a MongoDB team, we have a Redis team, we have other teams. So that was an option. The third option was to just build from scratch, just go and build our own operator. Now, given that we were, a lot of the people at the company were new to Kubernetes when we kicked this project off earlier this year, we went with the off-the-shelf operator for the POC. So we took the most capable operator that we could find in the community and used that for our POC and learned a lot. And what we really found was it did some of the things we want. It needed a little bit more functionality, but the real problem and the reason that we couldn't use it to go into production, or we decided to kind of make a break going into production, was it was developed a couple of versions of Kubernetes back. And so kind of refactoring the whole operator to get it up to speed and using the latest things ended up being a pretty big burden, and we would have to fundamentally change the way that operator worked. So it kind of made more sense to us at the time to really just start from scratch and for production build our own operator. Gave us a little bit more control, gave us a little bit more freedom, and it just seemed like it was a better opportunity than to have to go once again take somebody else's operator and completely fundamentally change it. The one thing I will say is that knowing what we know now, the CoreOS Kubernetes operator framework would have been really useful to us at the time. Like if we were starting from scratch today, we probably would have used the SDK to kind of bootstrap all of our operators. But once again, this is a common theme in Kubernetes that we're going to find. You make a decision, then somebody releases something that solves it better, and you have to kind of make the call as to whether you go back and refactor or you just move on. And then the final piece, another piece that's just going to be super high level since everybody else has done deep dives on it for a long time now. We couldn't do what we do without stateful sets. It's we need persistent storage with all of our pods. So obviously stateful sets provide that, but also stateful sets provide a whole bunch of utilities about how you deploy, how you scale, and how you restart your resources. So once again, I'm not gonna, we'll leave it at that and spend a little bit more time digging into the things that are haven't been covered as well. But going back to the easy meter, kind of calling that out, Making the operator decision was a little bit of a harder problem. Stateful sets, kind of landed in the middle because, as you'll see, there are some things we had to go kind of do our own work to make stateful sets do exactly what we needed for a database. But it's getting a little bit easier is pretty much the story here. So I'll turn it over to Wes for security.
Right. So now we have a basic cluster out there. It's built, it's running, but we need to find ways to run authentication. We needed to secure that traffic with certificates and a couple other things. And we also needed to worry about isolation, since we're hosting it for a company. Here's some grumpy cat. So I'm going to go with namespaces first. So namespaces as a whole in Kubernetes are kind of really easy intro concept. It isolates your components from other components within it. And you're able to apply some security, some restrictions, and things like that. People might not really use them when you're running your own tool set, your own apps, and things like that, because you don't need isolation as much, unless you have a whole lot going on. For us, though, we need to be able to isolate every customer from every other customer, and customers' staging environments from customers' dev environments or production environments. So we're leveraging namespaces along with a little bit of an overlay from WeaveNet to allow us to restrict all access into a namespace except from our ingress layer. Our ingress layer is how customers access. It's also how we run our admin tools against. Then once inside that, nothing's going to get in or out. No other customer is going to impact someone else. And it gave us a really easy way to just check a box, and now everyone's secure from each other. On top of that, namespaces are also going to give us a really strong isolation with secrets and config maps. Those are isolated to a namespace. So when we create a unique certificate for a cluster to encrypt communication, isolated from that namespace, it's hard for us to accidentally dump that certificate somewhere else or give someone access to it. Leading into that, and why part of these certificates are important, is how we manage authentication to the cluster now. So we've isolated it. Now we have to make sure people can securely connect to it. Elasticsearch on its own does not give you an authentication mechanism without a license. There are a couple open source projects. We went with SearchGuard. They're great to work with. If you're looking at things, they're kind of cool. They've got a good product. But what's important for this part of the slide deck is they have an admin tool that you need to run in order to apply configuration changes. There's no API. There's nothing like that. It's run a command, applies a manifest to your cluster. And it uses certificates to authenticate. For us to do that at scale, we looked at a couple different options. There's a centralized service. It's a very common practice. You distribute workload. You connect to a remote machine. You run off a queue. Pretty standard. Then we looked at what Kubernetes has, and there's a job workflow. It's really great. We can dictate where this container turns on. It gets access to these isolated resources, but you have to wait for resources to spin up, and you have to clean up your old jobs. It's not really a repeatable run. Then the next part was remote command. It's essentially just SSHing. It's like running a remote exec command with SSH in your container or VM and moving along. We ended up going with remote command because it allows us to not have to wait for resources to spin up. We directly connect to the container where the tool is to run the import of the new user list and update. It's secure. We're just connecting over the Kubernetes APIs. It's simple, it's lightweight, and it really helps solve this problem. The only cons in my opinion, you really never want to run more than one process in a container for an extended period of time. Here, we're kind of breaking that rule, which is okay. It's a 30-second run, and it buys us so much more. And it was kind of hard to kind of Stack Overflow our way around how to get examples for remote command. Not a lot of people are really using it, so hopefully when we eventually get our stuff out there, it'll be a good reference for folks. And then kicking into the next piece, we have database administration.
All right, so the first couple pieces are, once again, it's, they're the bare minimum when you're spinning up a new cluster, but that's, a lot more applicable to, kind of any database, not necessarily a database as a service. And so automating the administrative tasks, that's really where, kind of the database as a service kind of pieces start to click in, as well as the service features that Wes will talk about in a little bit. So some of the things we need to think about are, recurring tasks, things like backups, things that are, custom configurations, things, anything that a usual, database administrator would do. We have, once again, we're very support heavy, but we need to automate this when you're talking about hundreds or thousands of clusters. You can't be having people performing manual tasks all the time. So that's really the goal of all of these pieces, is to find the things that are the right things for us to go automate, make them part of the platform, make our support folks' lives better, but also make a product that just works once again, when we're offering it as a service. So the first thing that really made this easy for us, and is one of those things, once again on the easy meter, we're really getting into the green zone now, is config maps. Config maps solved a couple of really interesting scenarios for us. So the first of those is custom configurations. By default, we configure all of our clusters in the image using just the standard settings, and those settings are generally good enough for 90+% of our customers. But there is a subset that need either a specific setting or need a custom plugin or need some other things. Well, config maps and their ability to be mounted as a volume in the container solve this problem super easily. So first example is Elasticsearch is configured via a YAML file that goes in a config directory. For most of the common values, we're able to either use environment variables or other things to tune some of those settings. But for things that are brand new, things that we hadn't baked into the image, we can actually just overwrite that entire file using a config map volume. So what we do in our case is we mount that file in its own directory and then use the Docker entry point to kind of move that file into the right space. Now, anybody who's done this before knows you can go overwrite a single file in a directory with a config map volume, but there are some downsides to that. And so we wanted the flexibility of being able to control when and how those files get moved around, and we wanted to use it as a little bit more of a general purpose way to put files in place. So we decided to use a script to move things into the right place. The other option that we have, and this is for things where we wanted to just drop an entire directory into the container, is the second option here is to just take a config map, take the files in a config map, create a volume that has all those files, and then just mount that volume as a new directory somewhere in the container. There's a couple of examples, once again, specific to Elasticsearch, where this helps, but the overall idea is you can take any file you want, you can drop it into a directory in the container, and then basically that file will update kind of automatically as you update the config map. So it works out pretty well. We don't have to go roll containers for every single update to some of these files. Extremely useful. Once again, super easy. It was something that was a little bit harder on our older platform that Kubernetes just does really well. The other piece that's key, and core to database administration is the recurring tasks. And so 2 examples we had were backups, right? Every day at a certain time or some range of times, you're going to take a backup and you're going to retain some number of backups. Rather than having to, pick a job scheduler or pick some kind of task management system, Kubernetes has really great tools built in with respect to the cron job system. So it works like a cron job works. You pick a time, you pick an action, and it does that. It does what you tell it to do. But it also includes some nice, some nice settings around, well, what happens if the job fails? What happens if the container fails that's running that job? And so in the first example, in the case of a backup, when we create the cluster, we submit our CR, and what our controller does, one of the things that is an output of that initial create call is a cron job that runs at a certain time and takes a regular backup. We just use Curator, which is a tool I've talked about a couple of times, to do our snapshots on the new platform, but that one was pretty straightforward and pretty easy. However, we wanted a more programmable way of kind of creating arbitrary curator tasks, because snapshots are pretty standard. You take them at a regular time every day. It's not going to deviate much from customer to customer. But the way curator works, it's very specific to how you're using your data. You might have your own retention policy. You might have aliases that you want to manage. There's a lot of different things curator can do. And so this was an area where we actually created a new custom resource definition, and basically by submitting a custom resource, we're able to create arbitrary curator jobs and basically using the cron job system. What we do is provide the configuration in the spec of the CR, and what that turns into is a cron job with a config map mounted as a volume that has that configuration file that's specified in the original CR. So once again, it gave us a nice way to specify these arbitrary curator jobs and just specify the action file and the configuration for that run right in the initial manifester in the CR. So at this point, we really hit our stride. It's Kubernetes is just super, is delivering really well and making things really easy for us. So I'll kick it over to Wes for service features. Oh, sorry.
Oh, that's fine. So service features. So now we have a very basic cluster deployed for people. They can access it. They can secure it. We're giving them backups. There's some resiliency. But as everyone knows, when you're running a database, at some point you need to scale it. You need to add storage. You need to add more members. You want to do more replica sets. You need to update it to get over security fixes. And this is really where it gets to the next level. And we end up having a whole lot of conversations with product of, He actually picked this slide out, which is kind of fantastic. Very self-aware. But we need to update things. And every database has their own update mechanism, how you update each member. So we're going to circle a little bit back around to stateful sets, as Steve had mentioned earlier, how it gives you a rolling update mechanism. But before, just going to bring people up to speed a little bit of how Elasticsearch updates need to work. Elasticsearch is a data store. You shoot a node in the head or turn it off or restart it, it's going to try to self-heal. It's going to take things that were not primaries, it's going to turn them into primaries, it's going to move data around. And it's usually not too impactful on performance unless you have a large cluster, a busy cluster. You start moving a lot of data, you're going to have failed writes, you're going to have slower reads. It's a problem. But they do have a way to mitigate that, and it's just disabling allocation. You turn off its ability to self-heal, you do what you need to do, you turn the node back on, say try to heal, and it's going to see everything's there and we're okay. But if you're going to go ahead and run through a rolling update set with stateful sets, it's just going to try to hammer down every node, and you're turning off a node, applying the new change, shuffling data, the node comes back, it's shuffling data again, and you're going to do that within 5 minutes, your cluster dies. It just crashes. We tested it a bunch and it was kind of fun. So stateful sets actually do give you an ability to control that flow though. It's called partition rolling updates. And this is the thing where it took a little bit of digging. It wasn't really documented at the time. It was kind of a newer feature. But it allows you to just set a value of an ordinal and it works backwards. So you can say my stateful set's at a 5. I'm going to start at 5 and only that one's getting updated. Then you're going to move to 4 and it's going to get updated. So now you're at least controlling the flow of when a resource is impacted. And it's a little less detrimental than Kubernetes just running down the list immediately. The problem though is it's still just moving down, and we needed a way to take an action of disabling allocation, enabling cluster health, verifying cluster health, and ensuring that the data is not moving around too much, which is kind of where we get to the harder flows of complex updates and state management. To give you a little bit of context of what a more complex flow is than just restarting the cluster. Sometimes you want to update the cluster. So if you're updating, and Elastic has gotten better at this in later versions where minor and patch levels, it's pretty safe to do a live update. We're actually able to, we need to be able to update that member, verify that things are in a good state, maybe run some analysis tools against indexes as we move through each member of the cluster. There are times that we're going to want to remove a node from the cluster. When you change the size of a stateful set, Kubernetes just sees it as an update. It would just delete the member of the node. And then all that data is going to shuffle around. Elasticsearch, we have to say, evacuate this node and monitor that. And then when the node is empty, we can actually reduce the size of the stateful set. A couple other things that I was going to run through, but I just don't remember them right now. So over here on the right, you just see kind of a flow of what I'm talking about, where we're disabling allocation, letting the update run. It's going to update one member of the pod of the set, and then we'll enable allocation, verify health, increase the size. Kubernetes is only applying it to the newest member, and we're good. But we needed to manage that state. So when you're interrupting the flow and running these tasks, the Kubernetes has an event bus that you can query. On really busy clusters, though, that becomes an expensive query. You can, the operator can fail. We write all of these updates back to our control plane that we can query out, see what's happening and where we are, but that becomes expensive, that every time the operator turns on, it's going to query every single cluster that's deployed, hit our main API, and then see what the state it's in, and things like that. We ended up going with something kind of simple, really, and we just set a label on our stateful set with the event that is currently running. So when we're running an update, we're going to do a rolling update label for the state, and then we're going to set the ordinal, we're going to let it run through, and then when we do allocation, we set the label to allocation. And then we perform another action, we set what that action is. So if at any point this process fails, the controller is going to come online, we're going to see we're in an update set, we're going to see what ordinal we've hit, but then our controller is also going to know what we've done to the cluster. And then we do that by building a giant state map. Mm-hmm. The state map is kind of it's annoying, it's big, but it was the best way we could solve the problem. And it was challenging. As you can see, it's a little bit more in the red. And the state map is going to look like this. Every time we're going to run an update on a member of a stateful set, we're going to look at what that label is. We're going to run that label against an entire set of switch statements. Based on what that is, we're going to call a function, perform an action, and then update the label. And we're just going to keep iterating down the list. This specific flow is just the first part, which says I'm in an update state, and I need to disable allocation. And then it's going to go ahead and do a very similar flow, and a similar flow, and a similar flow. We actually mapped out all of our states, and we were about this tall, this wide, down to there. And we're going to end up having to revisit how to do this, but it's been working for now. I just think we're going to hit a problem, so might not be, the takeaway here is don't do this, maybe. We're actually looking at sub-resources which have come out, which are giving us a little bit more granularity on specific resources of states, of stateful sets and things like that. But yeah, this was kind of challenging, and it's kind of hard to keep in our head. And with that, we're going to move on to things we've learned and talk a little bit about that learning curve that Steve alluded to earlier.
Yeah, and so now that we have the labels on it, we had the idea, all the things guys come out of the woodwork, and it's going to be super easy, and it's just going to work, and Kubernetes does everything. And obviously, once we dug in, we didn't know, and so you got that first dip, right? But then, once you start to learn all the facilities and all the tools that are baked into Kubernetes, and you're keeping up with all the new releases, there's a lot of options, and so it got easy again, right? We hit the basics, it got really easy, and so we hit our stride. But then, to Wes's point with state management, you kind of hit the, you start to hit the things that maybe there just isn't a tool available to solve it for you, or maybe you just have to go write your own code or your own workaround to do it. That's when things got difficult again. But now what we're starting to see is, now that we've been through that, we've learned a lot, we're kind of hitting the upswing. But one of the things we'll talk about in a second is also, it's like, you blink your eye, there's a new feature that's now out with how quick the release, release cadence is on Kubernetes. We're finding it actually makes sense to, the longer you stay in the game, the easier things are going to get, just by the strength of the tools. The other piece that's been kind of interesting to us throughout this is, we tried not to repeat ourselves, so we tried to be super dry when we created the first CRD and our first, and we're submitting our first CRs to create our resources. The idea was, let's just create this massive CR that does all the things, and then basically, depending on all the different things we want to do in our cluster, we just provide different versions, or not different versions, different settings in the CR. What we found though is it made the code really dry, but it was super complex, and we had to handle a bunch of different conditions, a bunch of different states that made just the code harder to read, harder to manage. It made life a little bit harder. However, about halfway through this process, we started looking into just create a new CRD or just create a new CR for all the different things. Now, the downside of that is we do have to duplicate some code. There are some things that we could be more dry about, but the code has become a lot simpler. It's a lot easier to learn. It's a lot easier to ramp on, and it's actually a lot easier to kind of debug and work through. So it's a trade-off we made that might bite us later, but it's worked out so far. And Wes, you probably have
as Steven mentioned, so we added Curator to our alpha just recently, and that was not on my quarter plan originally. So he just came and was like, we have an alpha customer, we need to manage their indexes. Let's get Curator out there simple. So it was an afternoon to 2 days of work to just spin up another quick CR. We already have a bunch of CRs that do this, and just make it a little more specific, tune it a bit more to just manage a cron job, and take a config map. And it's let us really iterate very quickly on new features and respond to alpha criticisms, and actually requests. But like Steve said, it's going to bite us in the ass quite a bit. Because now we have, I think, 6 CRs, and 4 of them are really similar. So we're looking at some refactoring as some holiday homework across the team. And then we tie into the velocity of Kubernetes. And it's touched a few points where massive state machine, great idea 9, 12 months ago. Probably not a great idea now when we've hit that complexity. Another great example, so from the beginning, and I alluded to it before in how we update resources, we need a way to expand the storage on these EBS volumes that we're attaching to these pods. A year ago, there was no automatic magic way to do that in Kubernetes, even though you could do that with Amazon. So Steve and I are in a room, we're figuring out cost, what if we attach 2 volumes to it, what if we do these massive data swings, and we looked at the complexity and then looked at the roadmap and we're like, let's just punt on it. By the time 1.11 comes out, Kubernetes solved that for us. So really pay attention to the roadmap when you're building on it, and really evaluate the roadmap to really what you need to implement. Because as we're all noticing as we go to more of these conferences and talks, people are solving the problems as fast as you can, and Kubernetes is integrating it as fast as they can. A little bit of closing.
Yeah. So you all can try it. We have an evaluation program right now. We're kind of right between the alpha and beta. It's not yet an open beta, but by contacting us, we can give you some free resources to check out the new service. Kick the tires, provide us with feedback, give us some ideas on how you think we could make the product better. There's that link there. I also have some cards in the front here with a QR code, so you don't have to write that down or type it in.
And like 7 T-shirts.
Yeah.
That's all we could fit in the luggage today.
Okay, and then the other piece is you can look at our code. We are not
yet.
Yeah.
Not yet. So we started the project very much. We want to be open source. We're using all these open source tools. And then we had to start making decisions of, well, we need this component to send messages to this part of our control plane. And they were like, well, it's 100 lines of code here, or it's a brand new service here. So we started just getting lazy. But we are committing to, in Q1, we are going to try to get more of the tooling that we're using out there and visible to the community. We've hit pain points, we've learned a lot, and we've learned a lot from other people's projects, so we want to get that out there. And one of the recurring themes in the next quarter is decoupling some of our business logic, decoupling some of our control plane logic, and being able to open source this sometime next year, early next year. So we can get feedback and make it a better product for everybody. And then we're hiring. Engineering, sales, full stack devs, GUI devs. If you know Kubernetes, Go, any of those things. If you think this is interesting or we're mildly interesting, come and talk to us. We've got a couple more guys from New York down here in the front row. I'm sure you could ask them some questions too. Yeah, and that's it. We've got a couple minutes left. Anyone have any questions? Anyone want to be vocal? Anyone want to come up here? Thank you.
There's a question over here.
Yeah.
How did you handle the provisioning of local storage?
Yeah, so we're not using any local storage, and we're not on-prem right now. We're doing EBS volumes in Amazon, and we're looking at Azure, remote disks in Azure when we get there, and Google we're still researching. Though, after seeing what Uber talked about today with their storage, we're going to start investigating that for our really high-performance customers. Yeah. It's just harder to move resources around when you lose a node, and like I said, Elastic does not handle that very well on a big cluster, especially busy ones. Anyone else? Great, thanks guys. We really appreciate it.